Morning. Oh, that's good. Morning, TechBash, and thank you for having me. This is, I come all the way from the warm climate of Orlando, Florida. I like the climate here right now. It's supposed to get cooler. That wouldn't quite suit. So a little bit about me. I'm an Azure consultant at Nebbia Tech, and I joined that company recently. And I have been an Azure MVP past 26 couple of years. I also run the Orlando.NET user group. I've been involved in it for the past 5-6 years. Shout out, Orlando Code Camp is on March 30th. Feel like taking a break and coming down to my side of the country. Please feel free. If you need to contact me, I'll put this slide up at the end of this talk. And if you need to contact me, feel free to reach out at any of those through any of those media. Although I would recommend using Twitter or email. I tend to ignore LinkedIn a little bit, my bad. Okay, so agenda for today. As promised, we will discuss serverless using Azure Functions. We will discuss schemaless concepts using Cosmos DB. And then I'll have a small demo that will basically take stored data into Cosmos DB and react to that data using Azure Functions. So that's kind of my talk in a nutshell. Now, the reason I wanted to do this talk was, if you look at my title, or the title for this talk, it's Serverless and Schemaless with Azure Functions and Azure Cosmos DB. Buzzword, hot technology. I wanted to talk a little bit beyond that. I really wanted to dive into why you would do some of this. So if I have not addressed that question sufficiently by the end of this talk, feel free to we'll have a discussion at the end of this talk. One thing I wanted to do during the talk was go through my slides. I'll stop every now and then for questions, but I would like to do most of the discussion at the end, if that's okay with you all. Serverless. So you probably heard about this term a bunch of times, and some of you are probably tired of it by now. But again, it's serverless computing is basically the abstraction of servers, infrastructure, operating systems. You don't need to provision anything. You don't need to manage any servers. You can take your mind off of infrastructure concerns. It's driven largely by the reaction to events, which is what our systems are supposed to do. They're supposed to react in a way to events and triggers. And that's what we'll be talking about today. And because this happens in the cloud with fully managed services, there is very little plumbing and code, which is one of the great things. And also server management, capacity planning, everything is invisible to the developer. The main point is this, and Scott Hanselman describes this well in his blog post, which is where I got this image from. It's basically your code running on the server with a slider bar, and then you pay with a credit card. That encapsulates serverless in a nutshell. But of course, there's more to it. But if you wanted to describe it to a layperson, I think that would be the best way to do it. What I like about serverless, number one is it eliminates a lot of the plumbing code. So I am not concerned about opening up a database connection and closing it, or doing the same with a queue or Cosmos or any of the other type of services that's available. Serverless it reacts. It just it's code sitting out there, and it reacts to something which is as close as it comes to the promise of cloud computing. You really don't pay for it until your code starts reacting to an event or a trigger. And it automatically scales, by the way. Low TCO. What is TCO? Total cost of ownership. Actually, I should have asked you guys that question, but okay. It's total cost of ownership. It's basically the concept that you don't have to maintain a server, or you don't have to maintain the scaling. So you're saving on all the infrastructure costs and even the people who maintain that infrastructure. So overall, you get savings across the board. And I used to work for a startup before I joined my current job. And the concept of, this is where I picked up the concept of TCO. So, you're operating on a budget. You have to scale suddenly. You have to scale down suddenly. And all of this could be easily accomplished with the in the serverless world. So that's what I got into this for practical purposes. The other thing I like is it's basically focused, short snippets of code, and it's easy to test, easy to reuse. For instance, one of my systems, one of my functions basically sends out text messages and one sends out emails. And it can be reused across the board in multiple services, as long as I know how to hook it in. Schemaless, that's the next buzzword in here. Schemaless is basically the fact that so there's a whole bunch of ways of looking at this. NoSQL data stores often allow you to store different types of, for lack of a better word, records in the same collection or same database or same table, whatever the equivalent is. You could store the record of a person. You could store the record of a grocery item within the same physical or the same logical unit. And there is no hard schema. Now, the schemaless that we will be talking about is not completely different schemas, but it's somewhat, I have it in here, it's similar but not identical, if that makes sense. So you can have, and where this comes across often, or where you will come across this type of concepts often is in IoT. So in IoT, let's say you have a system that you are monitoring a bunch of sensors, and these sensors are made by different manufacturers. So they may send in the temperature, they may send in something else, but then they'll have a whole bunch of other fields that they send in that you may or may not have use for. So instead of going around changing a table schema to accommodate for this, you switch over to a schemaless data store. There are other advantages. It eliminates the need for an ORM, although I'm kind of interested in seeing how EF core that works with Cosmos now, how that whole thing works, because EF core is an ORM, so that should be interesting. On schemaless, basically the data is stored as key value pairs or JSON documents. For today's discussion, my context for schemaless is going to be document-oriented NoSQL databases. So it's basically a bunch of JSON documents. And that's what I was talking about, where it says similar but not identical data. That's what we'll be dealing with. It's more of a real world example, although the one I have today is probably, there are probably much better instances of this in the IoT world. The best part I like about schemaless is you can just discard null columns in most cases. I'll stop here. Any questions so far? All right, I'll move on then. So we are going to be discussing serverless with Azure Functions, so I'll lay a little bit of groundwork. What I want to do today is lay the groundwork, not dive into depth on Azure Functions or Cosmos DB, because that's like a day-long talk for each one, and I'll just touch on the basics that we need for today's discussion. Azure Functions. How many of you here have used console applications? Okay, like any kind of scripts console application. So Azure Functions is kind of a natural evolution of this. So we had console applications starting with early versions of the .NET framework. You used to run these on servers. Then came along Azure websites or Azure App Service. So what we did next was we took these console applications and deployed them in the website as web jobs. So you could now take your console application and run it in the cloud. But this was still, you're just running a console application. The scaling is limited to the size of the app service. So Azure Functions is kind of the next step in the evolution of web jobs. It takes everything that's good about web jobs and improves on them. Basically, you can write short snippets of code in your IDE, or you can even write it on your browser. I will not be doing the browser coding today because that's far too simplistic, and I personally don't like browser coding for Azure Functions, because I like to do a CI/CD environment that goes all the way from my local machine to live. So you have, for Azure Functions, you have built-in integration, so you can integrate with most Azure services like Service Bus, Queues, Stable Storage, Cosmos, and you can even integrate with third-party services like GitHub webhooks. So if someone checks in code into GitHub, you can get Azure Function to run using a webhook. It's a pay-per-use, so Azure Function, when it gets triggered, it runs, it scales, and after it's done, it automatically scales down, and you only get charged for that period. So that's one of the great things about Azure Functions, in general, the serverless world. Automatic dynamic scaling, and you can still run Azure Functions under app service, and people do that in certain instances. For instance, Azure Functions have something called a cold start penalty, which means sometimes they take a while to spin up, and I'll discuss this later. But you can put it, you can deploy Azure Function as an app service, and you can leave it always on so that you won't have that cold start penalty. So if you need instantaneous responses, that's one of the ways to do it. But then you are restricted by how much it can scale. So it's always a trade-off, which is one of the cool things about the whole serverless world. So I wanted to touch on this diagram. I think having a little bit of understanding of this diagram will feature later in our discussion. So Azure Functions, as we discussed, are event-driven, which means that they run based on certain events or triggers. And we'll talk about triggers in a minute. An Azure function can be triggered by a simple event like a timer. So you set a timer for every 24 hours, and boom, at the 24th hour, the Azure function will execute. Or it can be triggered by something like a file gets put into a document management system, and when it's uploaded to your SharePoint library, you can cause an Azure function to run. So, as you can see on the left side, there's a whole bunch of, this is just a small subset of the number of items it can get triggered by. And the part I wanted to discuss was the scaling part. So you have, let's take the example of a service bus. bus basically gets a bunch of messages, right? So how does the whole scaling thing work in Azure Functions? So service bus, let's say you get 10 million messages dumped on it at once, which happens, you never know. So there's something called a scale controller that's monitoring whatever infrastructure it's hooked up to. So it kind of looks at the oldest, in this case, it'll look at the oldest message in the service bus and the amount of messages left in the service bus. So, you have oldest about 10 seconds back, and you have 10 million messages. So the scale controller will know at this point that it needs to scale up to handle these events, or scale out to handle these events. So it'll automatically spin up multiple host instances to run this Azure function on, and then these host instances will process each message, and as they process and the queue shortens, they'll automatically start scaling in. So scale out, scale in, and that is handled in the background. You don't write any code, which is the best part of this. Again, I'll stress a lot on not writing code. So it's been a lifesaver. Another concept of Azure function I wanted to discuss was binding. Binding is how you connect your code to the infrastructure. Done properly, there is no additional plumbing code required. So in this case, if we read the bindings, and I'll try to read it from here, you have an incoming binding for a queue, and you have an outgoing binding for a table. And in the queue, the incoming binding is of type queue trigger, which means when a message or messages go into the queue, it triggers the function. And you have the name of the queue, which is the queue name, appropriately named. And then you have a connection, which basically says it's the name of the variable that stores the connection string to the queue. So it's not the actual connection string. The actual connection string will be in a different app settings type file. So you can deploy this to Azure function on Azure, and you can set the app settings directly over there. And as long as the name of the variable matches here, it'll work. And the top item, which says name order, that is the variable that gets used in the code. So I'll get to this in a minute. And in the next section, you have a return type. So that's pretty straightforward. It just this is what the function returns, and it returns a table. And as you can see, the direction is out, and then that's the name of the table, out table. And then again, you have connection string specified in a similar manner. Now, there are two ways of doing this. If you're using the Azure Functions web browser coding, they present the function.json file, and you can put everything in here and hook it up in code. In my code, because I like to code locally, you will see that I do a lot of the binding parameters directly in the code section. So the first one, function name, and that's actually not relevant until you use a HTTP trigger, because you can call a HTTP trigger from a REST client. So function name is not really relevant until you use that. And then you can see that it returns a table and that's the connection string for the table. The actual method, it returns an object of type person, and you can see in the run parameters, it uses a queue trigger, and the queue trigger simply reads from a queue with this name located at this connection. And this is the code. So what I'm doing is I'm reading the queue item, and you can see that over here it stores it into a variable order. So over here from the queue I'm reading the property name, and I'm reading the property mobile number, instantiating an object, returning it, which gets stored into the table. Now all of this happens in a few lines of code. I do not have to do any kind of plumbing, like open a connection to a queue, listen to it. I don't have to do any of that. I simply specify all my parameters within a few lines of code and it runs. So it's compact, it's easy to configure. You just switch out the name of the variables, or you play around with the code to decide what you want to do with it, and that's pretty much it. So we're good on Azure Functions so far, and we can have a in-depth discussion detail on whether this is a good practice or not. So, you know, I'm always open to suggestions. Yeah. If you used a JSON-based. Right. So if I use this, then I would not need this. I would be using a queue trigger, but I don't need any of this stuff in here. Right. That's, yep. So that's two different ways of doing it, and I wanted to show both ways. I will be using the second one because it's much easier to show it in code. How am I doing on time? Okay, Schemaless, and in the context of Schemaless, I will be using Azure Cosmos DB, which is my favorite Azure services server. So what is Cosmos DB? It is a service available on Azure. It's a fully managed database as a service. It is a series of NoSQL databases. So you get a document database, a table API, this is a graph database, and this one is Cassandra, which is a column-oriented NoSQL database. So you get a bunch of those on Azure. So you can spin up multiple types of data stores as the use case dictates. So that's another thing, just watch for the use case. Don't just use Cosmos table because someone told you to. What is the use case? So that's always something that should be at the top of your mind. The good thing about Cosmos, it's fully managed. It's a turnkey global distribution. So let's say I have Cosmos instance in the US, I can spin it up in Europe just by clicking on a point on the map, and it's fully functional within a few minutes. Keep in mind it still takes a few minutes to function at the full capacity. So if you're spinning up one in Europe and you have one in the US, you click on Europe, give it time to reach full capacity. So, and that's not more than a few minutes. You can add, and the cool part about Cosmos is, again, you can scale up and down. Cosmos uses something called throughput that depends on the amount of data it's processing per second. So with Cosmos, you can scale the throughput up and down. That is not automatic, but there are ways of making it automatic with code. And in terms of Cosmos, what we will be using today is the Cosmos DB-SQL API, which is previously known as DocumentDB. That's what we will be using for our demo today. Cosmos DB, like I said in my previous slide, also uses table API, graph databases, Cassandra. We will not be using any of those. We'll only be using the document-oriented data store, which is called the SQL API, previously known as DocumentDB. So if you come across DocumentDB, when you're writing code, some of the libraries are still called DocumentDB. That's where the name comes from. So this is the general structure, and I'm discussing this structure because it's very relevant to today's discussion. It uses, so a Cosmos starts at a top level. There's a logical entity called an account. An account will give you the URL that you can point your client to, that will talk to Cosmos. And it will give you the secret keys and the connection string. So that's what the account is for. The next one is a database. A database in Cosmos is not the same as a database in SQL Server. So it's just a logical entity again. And what a database does, it provides you the ability to set users and permissions. The next one is the most important entity, which is called a collection. A collection in Cosmos is, you don't get charged until you spin up a collection. So you can create a database, you can create an account, no charge. You create a collection, yes charge. And a collection in Cosmos is the physical entity under which data is stored. And how is data stored? Data is stored as documents, because this is a document-oriented database. And what type of documents are these? JSON documents. When you take JSON data, and as long as it's valid JSON data, you can store anything in Cosmos. When you put it into Cosmos, it will add a few more attributes to it. These attributes will basically be something like a link, a direct link to the document itself, so you can link it as a URI. There's also things to handle concurrency and other things. And also when you can expire the document. So you can put a document in Cosmos and you can say this document expires out after 24 hours, which is a great way to actually save on storage if that's a problem for you. Cosmos also supports stored procedures, triggers, and user-defined functions. These are JavaScript code running on the actual Cosmos server. So you write the JavaScript code, you attach it to the server, and it'll run. And it works pretty similar to the stored procedures and functions that we know in SQL Server, but beyond scope for today. Oh, and a document can have attachments. Again, we'll probably not discuss that. Now, this is the most important slide of this talk. I hope if you take anything out of this talk, it's this concept of change feed. So this is what is going to make sure our code works today. The serverless code reading schemaless data. This is what is going to make sure that works today. So it's called a change feed. And I hope to have a good discussion on this today, and then we'll jump into some code, and then we can have all the discussions that we want. So there are a few concepts to cause. What I would suggest is, maybe if you're interested more in Cosmos, you should attend this afternoon's talk by Jeremy, and he's actually giving a primer on Cosmos. And these are some other concepts that he will be discussing in more depth in his talk. I'll try to do the best I can, but this is kind of the second level of that. Cosmos, it's a NoSQL data store, and what NoSQL data stores do is they store, instead of storing data on one disk, they store it on multiple disks. And so basically they partition their data and they scale out instead of scaling up. That's the whole, I guess, building block of the NoSQL world. So what this means is that you have to pay close attention to how you partition your data. It's called sharding, if you may have heard of the term. You have to pay close attention to how you do this. You can, when you have a whole bunch of data, let's say in this instance I have data that's separated by city. That's each city is used as a partition in this example. As for the actual storage, these partitions are if there's not enough room, if there is more room left on a disk, it will store multiple partitions on one disk, on one physical disk, and it makes it, and then it uses something called a partition range. So we clear so far? There's partition, which is the actual data being stored. And there's partition, which is the physical separation of this data on disks. So in this case, the partition is by a city, and as you can see, there are multiple cities. So this would be a partition range. So each one is a partition, right? So how this change feed works is when data gets put into a Cosmos DB collection. So remember in the previous slide I had a collection, which is where all the data gets stored under. When the data gets put under the collection, this collection is monitored by a series of hosts. And this is the other side of it. Remember the scale controller I discussed in my previous slide, and how it spins up multiple instances and spins them down. So each instance is a host. So you can have your code running on multiple hosts, and as these hosts scale out, they also spin up threads, which are called consumers. So that's how it basically handles the scaling. This may be a little bit too much behind the scenes, but it's actually a good discussion, and hopefully it helps. So basically you have consumers spinning up, and these consumers are supposed to monitor these partition ranges for changes in data. Now, one of the tenets of the cloud is that you have to account for the fact that your infrastructure could spin down, go offline at any point in time. So what happens in this scale when you have, what happens in this case when you have multiple hosts that have threads that are monitoring partition ranges and everything goes down? So that is, you basically lost everything, right? Like you don't know where to proceed. So that is why they use this in-between entity called a lease. So a lease basically tells you, host 1 is monitoring this partition range, and this continuation basically says that it's on item number 4 on the partition range. The amount of data that's being changed in the partition range. So this is all the data that's coming in. Let's say five records come in. It's on item number 4. Actually, 6 come in. It starts at 0, so that's on 4. My bad. So let's say this goes down, or this suddenly loses connection, or it scales up, whatever the case be. When it comes back online, host 1 will connect to the lease database, and it will tell it that, oh, you were on index 4. So either finish that or move on to index 5. So that's, we good so far? Questions? No? Okay. Just want to make sure that I talked about this because we will be using this heavily. So maybe we'll refer to this in future slides. Okay, so in today's demo, I'll jump into the demo in a few minutes, but before that I wanted to talk about a few concepts. In this case, I have an Azure function that is that is somehow triggered, and it uses the output binding to store to the Cosmos DB. So this is one of the concepts that we will be using. The next concept we'll be using is, there's data being changed in Cosmos DB, which creates a Cosmos DB trigger that is processed by an Azure function. This is a third one that we will probably not be using, but I just wanted to mention that you can also do this. You have a trigger that triggers an Azure function that uses an input binding from a Cosmos DB to read data and then output it. So you can also do that. Today's example is a very simplistic one. At least the code I'm writing is going to be very simplistic, but it's basically to demo the fact that you have a checkout API for an e-commerce store, and this checkout API will cause some records to be generated on what got checked out on the e-commerce site, and we will calculate the tax and the payment and the shipping fulfillment, which is shipping. So I'll start with a couple, and as time permits, I'll keep going to the next. We good with this? Any questions so far? All right. All right. So I will put my code in GitHub. I do not have this code in GitHub yet because I was updating my talk for Azure Functions version 2, which is way different than Azure Functions version 1. So I was tweaking it late until last night, so hopefully this works. So a few things I wanted to mention before I jump into this demo. For today's purposes, I wanted to do my demo completely on my local development instance. I didn't want to go outside and connect to an Azure instance sitting up in the cloud. What I believe in is building completely locally and then using your CI/CD pipeline to do the testing and production deployments. That's what I believe in. So this kind of lends towards that. I am not going to show the CI/CD pipeline. I don't have the time to do that. So hopefully this helps. But my demo is completely going to be on a Windows machine. If you are using a Mac, I would suggest, instead of connecting to the local emulators, you connect directly to the Azure services. So that's one tip I can give. I'll be using the Visual Studio 2017 with the Azure development workload. I will have the latest version of the Azure Storage emulator and Cosmos DB emulator. So you can download all of these. Just Google and download. It's really, all you need is this slide, look up and download the latest instances of this. I will be using the toolset for Azure Functions version 2, which is very different than version 1. I shouldn't say very different, it's a little harsh, but they do use more of .NET Standard, .NET Core, which makes it different. I will be using some NuGet packages which will provide Cosmos support for the functions or for that project. And I have a sample app here that I built last night that I may or may not use as reference, just because. Okay, so I'll start from the ground up. New file, new project. I want to do an Azure Functions project. Can everyone see what's on the screen? All right, so I'll do an Azure Functions project. And this is where it starts to diverge. So if you have two different tool sets for functions, V1 and V2, you have to be careful of which one you select. I will select version V2, and what I want to do is, okay, so I'll describe what I'm trying to do. I will have a HTTP endpoint that I call the checkout API. This HTTP endpoint will receive two different sets of data, but it's related to the same type of product. So in this case, it's a music, let's say it's a music file, and it's coming from two different providers sold this music file, and they both are sending confirmations that we sold this. And I shouldn't say music file, and the music, let's just take a music CD, even though that's pretty outdated. And I want to do shipping. So two different providers sold a music CD, and it's coming to the fulfillment place, right? But they're sending some data that's related, some data that's not related. And I will have a HTTP endpoint that listens for this data, and then it will store the records into Cosmos DB, which will trigger functions further down the line that do the tags and shipping and other things like that. So I'll start with the HTTP trigger, and for convenience sake, I will set my functions rights to anonymous. You can lock down your functions at a function level or at the app level using this setting. So the function, when you create a HTTP function, it goes out and generates some plumbing. So you can see that in your local settings, it says, oh, Azure Web Job Storage. I'm using the local development storage. This is the storage emulator that runs locally. So this is for development purposes only. It shows what runtime I'm using, and as you can see in here, it's using a HTTP trigger. At the authorization level anonymous, it supports both GET and POST. I can customize the route if I want to, which we'll probably not for this demo. And it's listening for this HTTP request, and then it's using the logger to simply log information onto the console. So let's say I run this function. So this is the version 2, and it'll say that your function is available at 7071 API function 1, but I don't want it to be called function 1. So I will stop it and I'll call it checkout endpoint. I want a prettier name. So next time I run it, you'll see that it's available at checkout endpoint. So now I have two sets of data. So my first vendor sold this CD, and it has some properties. So you can see that it's a music CD. We'll change this so I don't run into issues. That's the name of the CD. So it has some data that's related. So you can see that there's the price, it has the name, it has the price. There are some values that are similar across both. But you can see that this one has a lot more details to it, and this only says 10 tracks. So the question is, will my endpoint not only read this, but is it going to be able to store it, and will my data store accept it? So we'll go through this real quick. So for convenience sake, I'm using Postman, which is a great REST client. So if you even take out of this talk that Postman is a REST client, I'll consider my work done. You can do a lot of great things with this. I could give an entire talk on Postman, but I diverge. Okay, so when I run this, I'm sending it to 7071 checkout endpoint, and so I send this, and actually I should probably put a breakpoint so we know it's working. Check. Okay, so when I send it, my function reads it, and it'll process everything, and it's supposed to say something other. So there you go, C# HTTP triggered processed a request. And if I look at my output for this response, it says hello, and it just read the name field and it returned that. So using this as base, I'm going to do a few things. So the first thing I'll do is, now one thing, I remember I told you guys about the Azure Cosmos DB emulator. So when you install it and run it, it actually runs in your system tray. And this is, it's a it provides pretty basic functionality. So, but this is all you need for development. So you actually can run it on localhost 8081. That's the port it usually runs on. And it also provides you with a connection string and everything that you can use in your application. So what we will do in this, close that. If you accidentally close it, you can come back and you can open the Data Explorer, which will get you back there. So you can see that there's currently nothing under here, and I want to connect to this and store data in it. And the data will be the CD information that I sent. So I need a few things to make this happen. The first thing is, looking at my previous project, I need this thing, this NuGet package, Azure Web Jobs extension Cosmos DB. So I will install that. Oops. So manage NuGet package. Okay, so that's it. That got installed. So if I look at the packages installed now, I have the Cosmos DB extensions, and the functions as DK and .NET Standard Library. So the next thing I'm going to do on here is I will need the Cosmos DB connection string. So I'll just copy paste this from here for the sake of convenience. Okay, so now I have a data store with a connection string. What next? So there's nothing else on here that I can really use. So I've got to figure out what else I need. So going back to this, I'll copy paste this and then I'll explain what I'm doing over here. Okay, so we'll deal with that. What I'm doing here is I'm saying that I have an output going to Cosmos DB at this connection string. Remember I talked about how you can partition data. So this is the partition key that you specify. Now, when I say schemaless, it's a little bit tricky on how to talk about this. For instance, even though I say schemaless, if I specify a partition key, that has to be present in all the records. Otherwise, you're simply wasting your storage. So if you have non-partition data, you can do that, or previously not partition data, you can do that, but it's you have to configure your Cosmos collection differently. So it depends on your use case. So this is my partition key. This is my throughput, which describes performance. And then remember how I said the database, and the database has a collection. So this is my database name. So I'll call it sales DB and sales collection. Now this kind of out of the box. One of the things I like to do is something called defensive programming techniques, which is when you're writing code for the cloud, never assume that a resource exists. Always check to see if it exists, and if it doesn't, create it. So this is what this particular attribute does, is if it doesn't exist, then it'll create it. So it's a lot in one parameter, but that's everything you need to do the plumbing. Why is it complaining? It's complaining because it cannot be async. All right. I'll simply have this as a void. Now there are different ways of doing this. You can make this async. It's just a different style of coding. Okay, so I probably want to make it async. So then what I'm going to do is I'm going to remove all the async code. So I'm reading the request body as it gets converted to a string, which I store in the request body. And then I convert this into a dynamic, and I'm assigning that dynamic to the output, which means that when this function executes and the code runs through the body of the function and exits, this will be sent to the output. The data will be sent to the output. And in this case, I'm telling that when the data is sent to the output, send it to this database send it to this collection that's stored under this database at this connection string. And if it doesn't exist, go ahead and create it. So that's a lot in a few lines of code. So now I'm going to run this and hope this works. This demos are always tricky. Okay, so it got up to this point and it's saying checkout endpoint. And let me see if it did anything over here. Okay, so far nothing. Next thing I'm going to do is I'll go ahead and send this again, this request again, and we'll walk through the debugger. So I'm using post to send this request. So all right, so this request has been accepted. Now it's gonna read. So this is the request body. So you can see that it's passing the album ID, name, the vendor ID, and other attributes, and storing it in a dynamic and then assigning it to the output document. So when this ran, I didn't get any error messages. So I'm going to go back in here and check. And it created my collection. And if you look under my collection, under the documents, it actually stored that data. Right? So nothing existed previously. It just, with a few lines of code and some plumbing magic, it just created it and it just works. It stores the data, and you can see that the extra attributes that are extra properties that I talked about have been added to the document. So in this case, that's the unique ID and the unique or the self URI, which means you can directly, if you have the proper permissions, you can access this directly from the using the URI over HTTPS. And the E tag is for concurrency, so that's and that's probably not a topic for discussion right now. And it also has a timestamp, which means that you can set it to expire, and it will expire after, or you can not have it expire and it will stay there forever. Okay, so it did that. Great. Now what next? Oh, will it do this one, which is also about a CD that's supposed to be shipped, but it has completely different data? Why don't we give it a shot? So I put it in here, run it, and it seemed to work with no issues. Okay, so I'm going to go in here, refresh this, and you can see that it stored my second record, which is completely different, not completely, but it's widely different than my first record. So the first step in serverless schemaless, I sent schemaless data, used an Azure function to store it into Cosmos. Now the next I'll jump to the next one in this. So I'm going to add a function 2. And in this case, so it's an Azure function. And in this case, what I want to do is when the data is stored in Cosmos, and the database name is SalesDB, and sales collection is the collection name. The connection string is something about Cosmos. I'll change that later. But I'm creating a Cosmos trigger. So when the data is stored in Cosmos, I want to react to this. So I'll go back to my other code snippet I created so I can figure out what I need. Okay, so SalesDB, Sales Cosmos DB connection. So I need the proper name of the connection string. I will assign that over here. How am I doing on time? Okay, all right. So okay, so you can see that it also wants to create the lease database. It has something for the lease database. So what we'll do is, since I want to create a lease collection, I will set this property to the lease collection does not exist. I will go ahead and create it. Then one of the things to remember is where your collection could get multiple records at a time, which is why I always use a list to read out of a collection. And then how to process this, I will simply put this code in here and discuss it, and maybe I'll have the time to run it, maybe not. But so since you receive multiple records, you could receive multiple records. You basically iterate through each one of them. Now this is really bad coding. I'm looking to see if it requires shipping, and if it's shipping is required, I could actually trigger another function from here, but that's a different story. We'll leave that for another discussion. But this is bad coding because I should probably check to see if this property exists or not. But for the sake of this demo, I'm assuming that this property exists on all the records. Don't do that in real life. So when this executes, it should create the lease collection, and it will listen for incoming and then run the message. Okay, so it generated 2 functions. You can see that it found the 2 functions, so it should work. We'll see if it generated the lease collection. So it generated the lease collection. So again, no code to create a lease collection, simply plumbing attributes. Okay, so I'll put a breakpoint in here. It should just walk through this, and then we will wrap up and take questions. So I'm sending another message. So it comes to the first endpoint, which means that this will store it in Cosmos, and it should, there you go. So it hits the next function, which is actually reading from the Cosmos using the Cosmos trigger. So you can, since it's just one document, we will directly jump into this. So it asks if it requires shipping. It requires shipping. So it actually it read this dynamic which are stored in as a JSON document, and I'm able to process it on the other side by using dynamics. So it says invoke shipping function. So you can do the same thing. You can create another function that calculates tax. You can create another function that updates your inventory. So again, you can do a lot of good stuff with Schemaless data in Cosmos DB. Now, I had a title for this talk called I Know Kung Fu. For those of you familiar with the movie The Matrix, it's taken from that. I kind of borrowed from that, but this is kind of the stage where you start to realize that you can do things in the cloud with real simplicity. So I will quote another or paraphrase another quote from that movie where Morpheus tells Neil that I can only show you the door. You are supposed to walk through it. So, I hope that this introduction helps you with writing code in the cloud and with disambiguating terms like serverless, schemaless, and what you can use Azure Functions and Cosmos DB for. So that's all I have. Thank you. Questions? No? All right, cool, thank you.